Now, just imagine you're bringing your airliner in foul weather, and suddenly the onboard computer in front of you freezes, and there's that spinning hourglass going on. Well, thankfully, that nightmare doesn't happen. And that's because the operating systems on aircraft are very different from the Windows or the iOS systems that we might use here on the ground. And that's thanks to companies like Mannarino Systems and Software, whose president and founder, John Mannarino, is with us now. John, welcome. Very quickly, give us an introduction to your company. Where did it all come from, and what is it you do?
Sure. Thanks, Alan. Nice to be here with you today. Mannarino Systems and Software was founded 20 years ago by yours truly. I'm a systems engineer at heart, and we've been working on safety critical, mainly airborne systems and software for 20 years now, developing software for all kinds of applications on an aircraft, from engine controls to flight management systems and aerial refueling systems.
So with these systems that you produce, with the operating system, what is different to the ones that we would use on the ground?
Well, the main difference is the operating systems on airborne systems generally are safety critical. There are lives at stake in the functionality that the software is performing. Therefore, that software has to be deterministic and always do the right thing, always do the safe thing, accomplish its function, its intended function as intended, and never misbehave, never slow down, never halt, never freeze. Always keep working to ensure the mission is succeeded, and that if there are unexpected events, that the software always handles it in a safe manner, which is very different than a PC or a laptop or your iPad, where at times we've all experienced a freeze, a delay, an application not working. That does not happen on aircraft.
And that always happens, John, does it?
It always happens. The software is developed with an engineering discipline and process discipline that is way above anything you would develop on a Windows type application, a PC type application. It's an extremely rigorous process that takes tremendous man hours and engineering effort and analysis and testing to make sure the software will always do the right thing. So it's a very expensive proposition to develop airborne software to that level.
So is the operating system, is it always aviation specific, or is this the stuff that they can also use in automotive and so on?
No, for sure. I mean, as you just alluded to in your intro, we have operating systems on our laptops. We have them on our PCs. They're used on any computational device where you have a microprocessor, a brain trying to accomplish a function. There are different levels of safety criticality, and there are different markets. Automotive is a market. It's actually one of the largest markets, obviously with the amount of cars out there. And operating systems are used extensively on cars in different subsystems to accomplish functions. There's also the medical device industry. There's all sorts of industries, industrial as well, that consider themselves safety critical. When we talk about aerospace, however, we talk about, people's lives literally being at stake, and you cannot reboot a computer.
Now, you're talking at Mannarino about specifically designing uniquely for aerospace, because it's quite expensive, isn't it, as well? So is that different, that you're doing it purely for aerospace?
It is different, and we are doing it specifically for aerospace. The company, over its 20 years, and even before I founded Mannarino, it's all aerospace pedigree that we had. So we know what's required in the aerospace industry in terms of functionality and safety and certification. We're well aware of the costs involved and trying to implement something for aerospace that is cost efficient as well. And we have targeted a design specifically for aerospace, meeting all the certification standards with a clean sheet design for optimum efficiency and for flexibility, so that we can tailor the operating system to different clients' needs. Not every system on an aircraft has the same level of criticality. an engine control, a flight control is the highest level criticality. There are other systems which are lower level. So there are different design assurance levels attached to pieces of software and different amount of work you need to do to get that software approved. So we are targeting our operating system specifically for aerospace and for all the variation of criticality you can achieve on an aerospace system.
So, John, who are your customers? Is it the airlines? Is it the airframers? Or is it the guys that write software for the avionics companies?
Essentially, our clients would be, they are varied. We can work with COTS hardware suppliers that are selling into aerospace and that provide hardware and then allow on their customers to write software. Our customers are also the ones who generate line replaceable unit items, an individual piece of electronics that does a very specific function, and of which there are many in the industry. And our clients are also the ones producing the most modern types of avionics, the integrated modular avionics, where they try and build multiple functions all in the same piece of hardware with proper partitioning of all the different applications to make sure they each work properly. So we will essentially serve all the clients who are buying or generating electronic hardware and writing software to perform functions on an aircraft.
Now, John, you mentioned earlier about the high cost of aerospace computing, really. And I've seen that you're talking about reducing costs by up to 50%. Now, that is really disruption, isn't it, for the industry? How are you going to achieve that?
It's absolute disruption, Alan, and that's exactly what we were aiming at. We have 20 years of experience doing this. During our 20 years, we've been a service company. So we have been developing software for our customers that perform all these functions, but doing that as a service. So we have learned over the 20 years about what it takes for the operating system and any piece of software to be designed efficiently. We have a great pedigree to do that. But we needed even more than that to get disruptive about this. We have signed an agreement with Lockheed Martin, one of the biggest aerospace defense technology companies in the world. This was an offset-related agreement. And essentially, through that agreement, we are able to fund the development of our operating system. And there are offset credits that Lockheed Martin obtains for this. So we have a unique situation where we have a good group of engineers with 20 years experience developing software that now have the financial ability to develop a product and put it on the market without having to recoup all of our initial investment costs. The combination of those two things allows us to just completely turn this market on its ear and come in with a very affordable offering. We're very excited about it.
Well, let's talk about software now. What do you think the aerospace and defense companies are struggling with as far as software goes?
It's one thing, Alan, it's cost. The amount of software on an aircraft has been growing exponentially for decades. There is more and more and more software on aircraft, and software projects have gotten larger and larger. The cost to develop aerospace software with the level of rigor required has just posed a tremendous problem to all of my customers, to anyone developing software for the aerospace industry. They are searching for solutions, and they need to get their software costs lower to make their business functional.
And so, as I understand it, you work with other software designers. I know you design your own software, but you work with others as well and get design approval, product development, certification. Can you explain how that works?
Sure. I mean, we've worked with clients in a whole variety of fashions over our 20 years. Generally, with software, even for a particular system on an aircraft, there's many layers of software that are required to actually get the computer to do the right thing and control the aircraft the right way. There's a bootloader software, which is very low level, that boots up the computer. There's an operating system, which really is the brain that controls all the applications and interfaces with the hardware to do the low-level processing required. And then there's higher-level software, application software, that knows how to control an engine, knows how to transfer fuel, knows how to perform navigation functions. There's many different knowledges, specialties required to develop aerospace systems and software. So we've worked at all levels, Alan. We've developed systems that control engine thrust on an aircraft where lives are at stake. We've developed software that does operating system. We've done bootloaders as well. It's a whole collection of expertise required to do this. What we're doing with the R-TOS is we've recognized, as other folks have, that the R-TOS is a core component of every avionics piece of equipment. You always need an operating system, just like you always need one for your PC or for your iPad or for your phone. Everything needs an operating system, which is fantastic from a manufacturer's perspective. I can sell it to many folks. But it's a core element, and it's always a required element. So we are trying to take that core element and take all our experience and our financial advantage and just give a revolutionary product to the industry. The industry is tired of paying way too much for an operating system. They are tired of being neglected as well. Aerospace, as we were talking about earlier, is a critical industry, but it's not the highest volume industry for electronics and for software. So the current market leaders in these areas for R-TOS sometimes don't treat their aerospace customers the way aerospace customers deserve to be treated. We are going to take care of that as well. At Mannarino, we've been servicing customers for 20 years. There's nothing like servicing a customer like being a service provider. It's in our DNA. It's in our blood. We work closely with them. We work closely with their application software developers. We work closely with their systems engineers. We work closely with their program management. We form a united team with them to get their product to cert. And we're going to bring all of that to our customers and really, hopefully, not only cut costs, cut schedule, just bring a whole breath of fresh air to this industry in terms of aerospace software and cost and certification.
And John, you talk R-TOS, and I think, just for clarification, that's real-time operating systems.
Absolutely. Yeah, absolutely, Alan. I mean, again, on a PC, things seem to be working in so-called real time, but every once in a while you have a glitch and you're waiting, or you have to restart something. You don't restart something on an aircraft. When you're taking off on a runway of fixed length and you have to clear obstacles, everything has to work in real time, deterministically, all the time. And that is what our R-TOS does, and that is what is required for aerospace.
Just must say, John, it's kind of amazing what goes on and the growing software requirements. Of course, as we move to a more electronic aircraft, as we're talking about, it's fascinating. And the fact you can bring those things through to certification for aircraft around the world and make them work safely and cost effectively, which is something I know the industry really demands. John, thank you so much for sharing the Mannarino story with us. Thank you.
Pleasure, man. Thank you.